I wanted to welcome Deb Donig to you. And she's a Belfer Fellow and a lecturer at UC Berkeley, and she's the lead PI on the NSF grant Assessing the Future of the Ethical Technology Workforce. And I'll give it over to you.
Hi, everyone. I realize I'm the person standing between you and lunch. So in addition to raising some questions, hopefully raising as many questions as I answer for you, and also leaving enough time to be able to answer any questions that you have, I get you to the next point of departure for a nourishing lunch and enjoyable conversations. But before I do that, I actually want to start with dinner. More specifically, I want to start with a dinner table. In September of 2019, I had just started a new job. At the time, I was teaching English literature at California Polytechnic University in San Luis Obispo. And I had arrived there as an English professor, and I was going to teach courses on human rights. And I had this nascent idea that you couldn't talk about human rights in the 21st century without talking about tech. That was my idea in 2019. This was before I would found a center on it, before I would begin to investigate and research the workforce at the intersection of those two things, tech and human rights. I had thought that this might be a good idea to teach a class on. And at orientation, at a dinner with undergraduate students, I found myself sitting at a table full of engineering students. And I told them that I was thinking of developing a course on human rights and ethics in tech. And I said I'd be delighted if they wanted to take my class. And one student replied with the confidence that only a 19-year-old could muster, that it would be very unlikely that he would take such a class. He was going to be an engineer. And he assured me, taken all of the ethics courses and knew everything that he needed to know about ethics from high school. And I've thought a lot about that student over the years, not because he was unusual, quite the opposite. He was the norm. He was, in fact, the product of exactly the kinds of educational and professional systems that we have built. He had been told implicitly over years, and he'd been told explicitly over years, that technical mastery and normative moral knowledge were separate domains, and that one is the province of engineers and the other is handled somewhere else by someone else, probably in high school. And that dinner, that confident dismissal crystallized something that I kept seeing. It was something that I would keep seeing over years, not just in college students, by the way, in product decisions, in hiring practices, in organizational charts, in the way that we built the very systems that now run our hospitals, our schools, our welfare agencies, and increasingly our research and our education systems, and their networks like this one. And I'm here today to share what 5 years of research revealed about the workforce that we are building to govern those systems and what that means for everyone in this room and every institution represented at this conference, I think. I want to be specific by what I mean by research. My book manuscript, which is called The Technological Grotesque, a term that I'll explicate a little bit later, which is forthcoming from MIT Press, is based on the analysis of 5,743 job postings collected between 2021 and 2025 by my team, along with 27 in-depth practitioner interviews from people who live in industry, academia, civil society, and government. So the question that animated that research, the question that animated the work that I was trying to do with this team was simple. What does it actually take to build technology that serves human values? And what gets in the way of doing that? And what I found should matter deeply to everyone in this room, because Cenic's work sits, I think, precisely at the intersection of infrastructure and human consequence. You connect more than 20 million Californians to networks that shape access to education, to industry, to healthcare, and to civic life. And how those networks are governed, who gets to interrogate them, and whether or not the people building and maintaining them have the literacy to ask the right questions, those are not abstract concerns. Those are operational imperatives. And as a coincidence, I was just yesterday giving a lecture to my students at UC Berkeley in my graduate course on ethics, human values, and informational infrastructure about what we mean by that word infrastructure. And in information studies, infrastructure refers to the underlying architecture upon which other systems are built. So power lines, we classically think of as infrastructure, water systems, broadband networks, and increasingly, digital infrastructure. Cenic is infrastructure. Zoom is infrastructure. Google is infrastructure. And infrastructure determines what gets built on top of what has been built, and who gets to decide how it works. Decisions made by people in this room will determine the future of what our infrastructure looks like. And of course, some actors want to build infrastructure in ways that primarily serve power and primarily serve profit. But I don't assume that that represents people in this room. If you were, you probably wouldn't be here listening to me talk about responsible technology. The people I want to talk about today are people who are doing something different. They're workers who are trying to steer technological production toward ethical, responsible, and public interest ends. So before I go further, I want to talk about who those people are, how they're trained, where they sit inside institutions, how much authority they have inside those institutions, and why their work so often fails. And one reason to do this is to help those of you who want this work to succeed put yourselves in positions where it can succeed. And another reason to do this is to help all of us build organizational structures that actually make such success possible. So let me tell you what I'm calling the great reversal. When we started collecting data in 2021, the responsible tech workforce looked a certain way. 58% of roles that I'm going to call human valued centered tech work in that ecosystem were what I would classify as ethical technology positions. And those ethical technology positions were roles that were focused on philosophical inquiry, normative frameworks, organizational cultural change. So if you are thinking about ethical technologists, think chief ethics officers. Paula Goldman, Salesforce's first chief ethical and humane use officer, is the archetype. She had an unusual background. She was at Harvard getting her PhD in anthropology and had worked in public service prior to coming to Salesforce. Zvika Krieger, who had joined Facebook as its first director of responsible innovation, had former to that been a Middle East correspondent. Yael Eisenstadt, Facebook's global head of election integrity, hired in 2017, had worked prior to that with the CIA on democratic initiatives. And these people held unconventional backgrounds, and they were briefly conventional for that kind of work. But by 2025, the landscape had inverted completely. Those ethical technology roles I described, the ones that were focused on asking, what should we build and why, those collapsed. They were 58% of the market in 2021. By 2025, we found that they're only 8% of that market. And meanwhile, technically focused, responsible AI positions, those surged. They were 33% of the workforce in 2021. There were 66% of the available roles by 2025. So in absolute numbers, of the 5,743 positions that we surveyed over those 5 years, 3,499 are now in responsible technology, 1,757 are in what I call public interest technology. Those are folks who are interested in regulation. And then just 487 in ethical technology. So in absolute terms, to interpret these numbers for you a little bit, this is a 50-point percentage swing in 4 years away from deliberation, away from questions that asked, what should we build and why, toward implementation, which merely asks, does our system meet some form of requirement? So one interviewee from my study put it this way. He's a major investor in social entrepreneurs, and I think this captures it precisely. The energy that was once about ethics and accountability has been redirected into safety, engineering, and compliance. The critique didn't disappear, it just got absorbed into technical fixes. Another interviewee from my study, an executive who had built AI ethics and directed ethics at a major tech company put it even more bluntly than that. Companies now prefer responsible AI because it's, and I'm quoting here, more palatable from a business perspective. Ethics, this professional noted, was too nebulous, more philosophical. By contrast, responsibility speaks to the risk and compliance people and to business motivations. And one lawyer and nonprofit founder I interviewed told me that companies are now afraid of the word ethics. And at IBM, they really had to scrub the word ethics from the description, despite the entire topic of conversation he was involved in being around about AI ethics. But there's a second finding in the data that I find even more troubling and than that kind of reversal, the 50-point swing that I talk about. And I call that the precarity experience paradox. Our analysis showed something very important, that there is a widening disparity in employment conditions across these roles. So ethical technology roles were nearly twice as likely to be contract roles or temporary roles compared to responsible technology roles. And while contract positions across all categories went to candidates with 0 to 3 years of experience, that compared to 21% of full-time positions. So let me make this concrete for you. Organizations are systematically assigning the most important, the hardest, the most complex moral and social challenges to their least experienced workers, while structuring those workers' employment to ensure that there's minimal lasting influence. One practitioner that I interviewed, I'll quote here, a high-level trust and safety strategist who had worked at major tech companies, said it plainly, and I'm quoting here, "The hardest, messiest problems, the ones about justice and bias, were assigned to junior contractors with no power. They get the least security to work on the biggest questions." I call these workers ethics tourists. They're there long enough to provide legitimacy, but they're absent at crucial decision-making moments. A junior contractor who's conducting a 6-month study on algorithmic bias audit cannot develop the institutional relationships, the cultural literacy, or the strategic positioning necessary to implement meaningful reform. You have to be inside, in other words, to change the inside. And what I've described is not just what I'd call a workforce problem. It's an epistemological problem, a crisis in how we organize knowledge, expertise, and accountability in technological development. And I want to explain why that works to this audience. And in order to do so, I need to introduce a concept from my book. And that concept I call the technological grotesque. I take that term from the idea of the sublime. And in aesthetic theory, and this is the only thing you need to know about aesthetic theory in order to understand this talk, aesthetic theory calls the sublime a feeling of awe that we experience in the face of something vast and powerful and extraordinary. In modern technological culture, the feeling often attaches to feats of engineering, systems that seem to transcend distance, scale, and human implementation. When I think of this, I always think of the Golden Gate Bridge, that classic bridge that spans the landscape, defines the landscape. I look at it and I marvel that human engineering accomplished this tremendous structure, one that allows us to navigate that terrain. So if you've encountered the Golden Gate Bridge, or the moon landing, or if you remember the first time you video called somebody on the other side of the world, you're encountering that kind of engineered awe. So the technological sublime, in other words, celebrates the apparent triumph of human ingenuity. Networks that collapse distance, platforms that expand access, AI systems that process data at scales that no individual human being could manage. It's the feeling that technology can exceed the ordinary limits of human capacity. So the grotesque then describes something that is simultaneously magnificent but also distorted in its very magnificence. It's beautiful, but it's also monstrous at the same time. So think of gargoyles on a cathedral, right? Sublime architecture combined with grotesque figures. The sublime and grotesque, in other words, are not opposites. They're part of the same building. They're two sides of the same thing. And I use this frame to describe what I see happening in contemporary technological development. Because when social networks are designed to connect the world and instead become instruments of manipulation and misinformation, that's the technological grotesque. When AI systems that are built to democratize expertise encode and amplify historical patterns of discrimination, that is the technological grotesque. And when human platform architectures that are marketed as empowering users reduce human dignity to engagement metrics that are optimized for advertising, that's the technological grotesque. And the grotesque, I want to make this clear, does not emerge from failure. It emerges from the technologies doing exactly what they're supposed to do. It emerges from a kind of overrealization, from narrow design priorities that pursue efficiency, that pursue growth, that pursue engagement while ignoring broader questions of values like dignity and equity and democratic deliberation. So I'm telling you this not as a abstract philosophical observation, although if you want to talk philosophy with me, I'm happy to field those questions, but because it's directly relevant to what you're doing and what Cenic is building. Cenic operates 8,000 miles, if I understand it correctly, of optical fiber, connecting more than 20 million Californians. You serve K through 20 students, researchers, libraries, public institutions. The network itself is magnificent. It's genuinely sublime architecture, in my view. But the grotesque question is always nearby. Who benefits? Who's left out? And which communities gain access to what forms of opportunity, and who has the literacy and authority to interrogate the AI systems increasingly operating across these networks? Now, I want to introduce a figure who recurs through my book because I think he's more useful than sometimes we actually treat him. And that character is Victor Frankenstein. I'm referring here not to the monster, but to the scientist. Dr. Frankenstein's catastrophic failure was not that he lacked technical competence. He had extraordinary technical competence. He reanimated the dead, right? But it was also not that he lacked ethical consciousness. He experienced what his author, Mary Shelley, describes as breathless horror and disgust when he was confronted with what he had created. His failure actually lay elsewhere, and that was in his willingness to dismiss ethical thought in pursuit of scientific discovery, and in his inability to cultivate what I call institutional wisdom, and that's the capacity to integrate ethical reflection and technical development from the earliest stages of product development and within collaborative rather than solitary structures. Notably, Dr. Frankenstein worked in secret. That was a plot point. He consulted no one about what he was doing. He didn't have anybody to challenge him. He acted what I like to call a lone cowboy outside of any social context that might have provided checks or balances or consideration of consequences. If this sounds familiar, it's because it is. This is our time. The release of ChatGPT in December of 22, the brief removal and reinstatement of Sam Altman in November of 2023, that was resolved not through democratic deliberation, but by employee pressure and investor power. In an industry where leaders call for regulation and the abstract while lobbying against specific rules that would constrain them, you will find Frankenstein's monster. And this is Frankenstein's laboratory. It's scaled now to the infrastructure of the 21st century. And the workforce data that I've shown you is the labor map of that laboratory. The people in it, their tenure, their authority, and whether or not they have the tools to raise the alarm before it's too late. When I think about this, I sometimes think about Building 20, when I think about what I think that laboratory should look like. At MIT, during and after the Second World War, there was a temporary structure that was built, and it was built to house everybody who didn't quite fit in to any of their own individual departments. It was literally built in haste for wartime radar research with a whimsically chaotic layout. It had confusing wing arrangements, and room numbers were seemingly assigned at random. Researchers constantly got lost in the building. They encountered colleagues from entirely different disciplines. And Building 20 in its chaos became one of the most productive research spaces in MIT history. Amar Bose founded his corporation after wandering into the acoustics lab while procrastinating on his dissertation. Noam Chomsky revolutionized linguistics through daily conversations with Morris Halle in adjacent offices that he described as, and I'm quoting here, the two most miserable holes in the entire whole place. High-speed photography, the physics of microwaves, the foundational work of linguistics and cognitive science, all from a building that was supposed to be temporary. The thinker Jane Jacobs called this knowledge, this kind of dynamic, knowledge spillovers. And when enough people with genuinely different perspectives run into each other in unpredictable ways, innovation happens that could not have been planned, and no planned collaboration could replicate. So now let me describe to you the opposite of Building 20. UCLA, which is where I completed my PhD, was famously divided in two. If you go to UCLA's campus, you'll hear people refer to North Campus, which is the campus that houses the humanities, and they have Gothic buildings, and they have gargoyles and a sculpture garden. And then the social sciences and the sciences, South Campus, houses all of STEM. And they had functional AV equipment and bathrooms on every floor, and also square communist buildings. The geography made it entirely impossible for computer scientists and philosophers to connect. It made it entirely possible, is the opposite of that, for computer scientists and philosophers to spend years on the same campus without ever meaningfully encountering one another. And the result was not productive interdisciplinarity, but mutual insulation. I now teach at UC Berkeley School of Information, and my course is one of the few places in the curriculum where students are asked to think explicitly about socio-technical dimensions of their work. And what strikes me every time is this. First, how much these students care about questions of human rights, social context, and values. And then what strikes me second is this, how fragmented their shared normative vocabulary remains. If I say RAG or GraphQL or Agile, everybody knows what I mean right off the bat. But if I say positionality or justice or fairness or privacy, and I press them on those points with any rigor, the shared language starts to thin out. We start to get abstract about the conversations, and this is not a minor gap. It's the gap between knowing something is wrong and being able to name with specificity, to be able to reason about, and to be able to act on it collectively. What I try to give my students is a shared vocabulary for articulating normative questions, the same way that they would share a vocabulary for Python and machine learning. Because if the ability to prioritize these concerns depends on knowing what to call them, then we need to know what to call them. And being able to name them with your colleagues so that you're talking about the same things, so that the things that you are talking about refer to things in the real world, is important. Because if words don't refer to real things, and if we can't agree on what they fundamentally mean, I'm not sure what they're really good for. Our educational structures as they exist currently are failing, and they're failing in three, I think, important ways. First, in what I call epistemological segregation. Computer science programs teach machine learning fairness and privacy engineering, but rarely engage with philosophical questions and frameworks for moral reasoning. Policy programs teach regulatory frameworks, but lack the technical literacy to teach algorithmic systems and how they function. Ethics programs develop sophisticated moral frameworks, but oftentimes the people developing those frameworks have very little ideas about how the technology actually works. So they can't talk to engineers about how to implement those frameworks. So we have specialists who cannot collaborate across epistemological boundaries. And that is exactly what contemporary socio-technical challenges require. So second, the scientific imperative fallacy. So folks in this room may be familiar with the Stanley Milgram shock experiments that were conducted at Yale. This often gets confused with the experiments conducted at Stanford. So I'll just take a second to explain what those experiments are. In those experiments, one group of people were asked to shock a second group and to administer those shocks. They were prompted to do so. And they could see that in administering those shocks, the other group was suffering. They could see that pain. Of course, the pain was staged, it wasn't real, but the outcome was that knowing that they were going to deliver pain to their human counterparts, the participants shocked their companions anyway when they were told to do so. So the classic interpretation of this experiment is that people will obey orders when they are confronted with an authority asking them to do something. But more recent analysis of those shock experiments actually showed something different. These experiments, which were conducted by the psychologist Gina Perry, found that the crucial factor was actually not, as is classically understood, blind obedience to authority. It was something different, and it was this, that participants were told that their actions served the cause of scientific progress. The most effective prompt in that experiment was telling the experiment group that the experiment requires that you continue. The experiment requires that you continue. And as one participant said in the debrief, I figured that this was for science and it was worth the cause. We teach technologists the rhetoric of scientific progress and to celebrate that scientific progress without teaching them to interrogate it. We give them the white lab coat without the capacity to question what they're being asked to do when they're wearing it. And finally, third, the absence of institutional wisdom. This is what I referred to as the missing ingredient in Dr. Frankenstein's laboratory. And by this I mean not just individual ethical reasoning and the capacity to do that, but organizational and systemic capacities to interrogate ethical reflection with technical development across a full life cycle of product development within institutions that involve multiple stakeholders operating under different incentives. That's institutional wisdom, the ability to navigate power structures, to build coalitions across different logics, to translate between different frameworks for understanding value. That's what enables responsible technology professionals to move from what I call ethics tourists to embedded agents of change. And it's almost nowhere in the curriculum. It's nowhere in what folks are majorly taught to do once they get into an institution. I want to pause on this diagnosis and give you something that I'm hoping you can actually use. I've been talking about a workforce crisis and an epistemological problem, but this is also a room full of people who run networks, who build infrastructure, who govern institutions and design curricula. You don't just need a diagnosis. You need a framework, I think, for building something better, and that's what I'm trying to offer here. And this is a framework I've developed from the research, one that I call the 3 registers of AI literacy, and it's designed to be implemented at scale. It's designed to be implemented across the diversity of institutions that Cenic serves, from a rural community college to a major research university to a public library in an underserved neighborhood. And each register represents a distinct layer of a capacity that institutions need to build, and each has a concrete curricular and workforce implication. I'm going to talk about these 3 registers, and I call them 1, functional literacy. That's understanding how AI systems work. 2, generative literacy, shaping governance and policy. And 3, critical literacy, interrogating assumptions and interrogating its impact. So the first register is functional literacy, and that's the technical layer. It's the prerequisite for almost everything else. And I want to be clear, in this talk I am not dismissing the technical dimension of how things work. Students and professionals need to understand how machine learning systems function at a level sufficient enough to reason and interrogate their behavior. What does a training data set do? What does a model's objective function mean? What does it mean for a system to hallucinate? What is the difference between correlation and causation in a predictive system? And for K through 12 institutions in Cenic's network, this means that computer science education goes beyond coding syntax to include what I call conceptual fluency with how algorithmic systems make decisions. For community colleges, it means stackable credentials in data literacy that are genuinely accessible, not just requiring calculus as a prerequisite for understanding how AI affects your life. And for research universities, it's a baseline for computational literacy across all programs, not just computer science programs. And the key principle in this register is this: functional literacy must be universal, not siloed. The nursing student needs it. The social work student needs it. The K through 12 civics student needs it. Every person who will interact with an algorithmic system, and that's everybody, I would say these days, needs sufficient functional literacy not to be deceived by a confident sounding system. The second register is where most digital literacy frameworks stop too early, and it is where the research says the work is most urgently needed. Cultural literacy means the capacity to interrogate algorithmic systems, to ask not just, how does this work, but questions like, who built this? For whom? Optimizing for what? Trained on whose data? Evaluated with what standards? And accountable to which stakeholders? This is not a soft skill. This is a rigorous analytic skill, and its capacity to draw on history, social science, law, and philosophy. And the evidence from my research is that professionals who are trained only in functional literacy, who know how the machine works, but not in ways that ask whether or not it should, are exactly the kind of workers who end up perpetuating the harms that the system was supposed to be designed to prevent. So let me make this concrete for the equity dimension, because this is where the stakes, in my view, are highest. We know from extensive research that algorithmic systems frequently perform worse for the populations who are most harmed by its errors. Facial recognition systems have substantially higher error rates for darker-skinned people and for women than for lighter-skinned men. Predictive policing tools are trained on arrest data that reflect historical patterns of discrimination enforcement. Automated resume screening systems are trained on historical hiring decisions that excluded women and people of color. When these systems are deployed in California schools and courts and healthcare settings and public agencies, they're being deployed in communities that bear the greatest cost of algorithmic error. And these are the communities that also have the fewest resources to challenge those decisions. And access to AI tools without the capacity to interrogate them is not equity. It's a new form of the digital divide. And in some ways, it's a more insidious form of the digital divide because it's invisible. A student who can't get broadband knows they're being excluded. A student who has broadband but can't evaluate the ways that the AI tutoring system that is making decisions about their academic trajectory may not know that they're being harmed at all. For curriculum design, critical literacy means this. Every single course that employs AI tools should include structured reflection on how those tools work and who they serve. For workforce development, it means hiring and training AI evaluators, not just AI implementers, but AI evaluators in institutions that deploy these systems. And for procurement, it means requiring algorithmic impact assessments before deploying AI tools in contexts that affect vulnerable populations and building community input from those populations that are most likely to be affected. So now I'm going to talk about that third register, generative literacy, which I think is actually the most ambitious and also the one most absent from current practice. Generative literacy is the capacity not just to use or critique algorithmic systems, but to participate meaningfully in decisions about how they're built, how they're governed, and how they're constrained. It's the difference between being a consumer of AI and being a citizen of the AI era. And for professionals in research and educational institutions, generative literacy means this. It means understanding how to write meaningful AI policy at the institutional level, how to participate in regulatory practices and processes, how to engage in the kind of rulemaking processes that are actively underway right now on the federal and the state level, how to serve on review boards, how to serve on governance committees that evaluate AI deployment, and how to design community engagement processes that bring in the perspectives of affected populations before deployment, not after the harm has already been received. And for students, particularly students from historically marginalized communities, generative literacy means this. It means understanding that you have standing to participate in these decisions, that the AI systems that are affecting your life are not inevitable, and they're also not immutable, that they're designed by people making choices, and that those choices can be different. This is not naive optimism in my view. It's a factual claim. AI systems are designed by people, they're deployed by institutions, and they're governed by policies. And all of these are human decisions, subject to human influence and democratic accountability. And the most important thing a research and education institution can do to close the equity dimension of the digital divide is to invest in producing not just AI users, but AI citizens. AI citizens, people who have the functional literacy to understand how systems work, the critical literacy to interrogate them, and the generative literacy to participate in shaping them. So what does implementation look like? Let me offer you 4 concrete strategies that institutions in this network can begin to use right now. Strategy number 1, audit your current AI deployments for equity implications. Before you add any new AI tools, take stock of what you're already using. For each system, who and what was it trained on? Who evaluates its performance? What are the error rates for different demographic groups? Who bears the cost of errors when errors occur? What is the appeal and the contestation process for somebody who is harmed by an incorrect output? Most institutions I've discovered that deploy AI have not answered these questions. And answering them is the first step to responsible deployment. Strategy 2, interrogate critical AI literacy and integrate it into existing courses rather than creating standby ethics modules or ethics courses. Everybody's taken one of those, HR courses that come along and you have to pass it in order to continue working, otherwise they shut off your computer access or something like that. I'm not talking about that. What I'm talking about is integrated curriculum. The evidence is clear that standalone ethics courses have limited transfer. Students who take these courses learn to ask good questions about algorithmic systems when those questions are embedded in courses, where they're actually building and using those systems. But in the separate modules, they actually forget. They complete this work and then they forget it. A data science course that builds in a weekly interrogation of the tools being used is an integrative course. A civics course that examines how AI is being used in local governments is an integrated course. A health science course that examines algorithmic tools and decision support for clinical contexts is an integrated course. This is curriculum integration, not curriculum addition. Strategy 3, building community advisory structures into AI governance. And for institutions, particularly for institutions serving historically marginalized communities, community colleges, public libraries, K-12 schools in under-resourced districts, this is not optional. This is the difference between deploying AI responsibly and deploying it extractively. Community advisory boards for AI deployment decisions, participatory evaluation processes where affected populations can surface concerns before they are rolled out at scale. Mechanisms for ongoing feedback and contestation after deployment. These are not expensive, but they're organizational choices. And finally, strategy 4, that is deploying what I call boundary spanning roles. And my research shows that the most effective responsible technology professionals are those who are able to speak across the epistemological boundaries and move across the epistemological boundaries between technical implementation, policy, and normative reasoning or ethics. And these kinds of people are rare, but they don't need to be rare. They're rare because our educational system does not produce them systematically. In institutions that create positions that are explicitly designed for boundary spanning, that reward rather than punish people who work across departments and disciplines, those are the organizations that create the conditions for the kind of integrated thinking that responsible AI deployment requires. A community college that, for example, hires an AI literacy coordinator who sits across the computer science department, the social science faculty, and the student services office is a very different kind of institution than one that, for example, assigns AI governance to the IT department alone. And I want to make this practical. Cenic's member institutions span community colleges, K through 12 schools, public libraries, the CSUs, the UCs, and private research universities. And you are collectively the educational infrastructure of California. And you're increasingly being asked to deploy, support, and govern AI systems across all of these institutions. And what this means is that digital literacy cannot just simply be about how to use technology. It has never been enough to teach people how to use tools without also teaching them to interrogate those tools. Literacy in its original sense means this. It doesn't mean just the capacity to read, but the capacity to question, to critique, to interrogate, and to produce. We would not consider somebody literate if they could just decode words but couldn't evaluate an argument. Digital literacy has to mean the same thing. It has to mean the capacity not to just use algorithmic systems, but to also interrogate them. So there's 3 questions that I think that every institution should be asking. And the first is this: who in your institution has the authority and the expertise to interrogate the AI systems being deployed? Not just to implement them, not just to comply with the vendor requirements, but to ask, who does this system serve? Whose data does it use? What assumptions are encoded in it? And who does it systematically disadvantage? If the honest answer is, we don't have that person, or that person is here, but they actually have no authority, that's a structural problem worth naming. The second question is this: is the equity question embedded in your procurement and deployment processes? The digital divide, and I'll say this more concretely here, is not just about access to bandwidth. Though Cenic's work on that is essential, and although it's important, it's also about whether or not the communities that have been most harmed by historical discrimination have the literacy to understand, to critique, and to shape the technologies that are being deployed across their schools, libraries, and civic institutions. Research consistently shows that communities of color, communities with fewer resources, and communities with less political power bear disproportionate impacts from algorithmic decision-making and have the fewest tools to challenge it when that harm is incurred. If your institution is deploying AI-powered tools in a community college serving first-generation students from underrepresented communities, what would responsible deployment look like in that context? And third and finally, what are you building into your workforce development and curricular pipelines right now? The students coming from your institutions today will be building and governing the AI systems of 2036. My data shows that the workforce currently being produced is technically competent, but epistemologically fragmented. People who can organize and optimize algorithms but can't interrogate them, can't situate them in historical context, can't ask the normative questions about what they should be optimized for. And changing this requires deliberate intervention on the curriculum level and across institutional boundaries. Now, this is largely a critique, but I don't want to leave you only with a critique, because the critique is not the end point. It is, as I write in my book, a clarification. What I think of as sometimes the failure of the first wave of corporate ethical technology has stripped away a kind of performative nature to that work and has revealed the true nature of what I think the challenge actually is. And that clarity is the foundation for something more resilient. And the question I sometimes ask myself is this: what would a California model of responsible AI literacy look like? One that took seriously Cenic's network breadth and equity mandate, and that came with serving 20 million users. And as I end here, I want to return to that 2019 dinner table. The student wasn't wrong to trust in technical expertise. Technical expertise matters, and it matters enormously. It's the foundation on which everything else is built. But what he was wrong about is that technical expertise is sufficient. The moral work is done in high school. That's what he was wrong about, that those two domains are and should remain separate. And 5 years of research have shown me that this separation is not natural. It's not a natural fact of the world. It's a structural choice. It's a choice that's embedded in educational systems and institutions, in org charts, in hiring practices, and in funding mechanisms. And it's a choice that we have made repeatedly, and it's one that we can unmake if we choose. The responsible technology workforce that I have documented and that I document in my book was at its inception built by people who believed that technical mastery and moral reasoning could and should be brought together, that engineers and ethicists and public advocates and communities could collaborate and build technology that was genuinely aligned with human values. And the data shows that this vision was, in many respects, never fully realized. It wasn't wrong, it was just never fully realized. And the field's professionalization has, I think, paradoxically, reproduced many of the fragmentations that it was meant to overcome. But I want to be clear about something that my interviewees told me and kept returning to when I asked them about what they had initially said in 2021, when I interviewed them in 2025. It was this: the failure of the first wave is a clarification. It's a clarification, not a conclusion. And it tells us what doesn't work. It tells us that performative ethics and box-checking compliance are insufficient, that you can't change a culture with a junior contractor and a 6-month contract. It tells us that access without literacy is not equity. But here's what it doesn't tell us. It doesn't tell us that this project is impossible. Institutions like the kinds represented in this room, institutions with genuine public service mandates, serving 20 million Californians, connecting communities to knowledge and opportunity, this is exactly where a different model can take root. And that student at 2019 dinner thought he had already learned everything that he needed to know about ethics. He's graduated now. He's in the workforce now. But there's a new set of students coming in this September, and I hope that by the time they graduate and by the time they enter the workforce, what they encounter are institutions that are willing to complicate that assumption, that institutions have built the capacity to ask not only whether technologies can be built, but whether they should be built. For whom, at what cost, and with what kind of accountability. And that's the work. And I think it begins here, and I think it begins, as they say in the context of the World Wide Web, with the right connections. Thank you. I'd love to take any questions I have at the time I have left.
Does anybody have any questions? Yeah.
Thank you for that really, how do I say this? Let me say, I am, first of all, I'm Jeffrey Weekly from UC Santa Cruz. I am Director of Research Computing there, but I'm also a PhD student in Baskin Engineering, and my dissertation topic is using generative AI and embodied AI to scaffold skills in supercomputing. There's often a gap between what I can train people to do and what they really need to do to be successful. And so my question is, as I'm thinking about how do I build a digital tutor in this particular area, and I'm focusing on students who have differences in learning, people who may have mild ADHD or mild dyslexia or other cognitive differences, or students who come from backgrounds that are non-STEM, how do I consider, given the framework that you've presented, what would be the first step I could take to consider an ethical design as I am conceiving this system?
Great question. And one of my favorite conclusions from years of research and talking to practitioners is that the first step is building in the ethics, asking the ethical question from the inception, which is what exactly you are doing. Sometimes I encounter people who ask me to advise their startup, and they say, okay, we built this startup, we've developed the technology, we're excited about deploying it, but how should we think about the ethics? And I said, meaning that you're ready now to scale it, and now you want to start thinking
Build a time machine, go back to the start.
And sometimes I think that these systems get built and then somebody wants to add ethics on top of it, like a prosthetic. And what we've discovered over and over and over again is that that doesn't work. Ethics really has to be built in from the get-go. And the reason for that, I think, is pretty clear, because the question of what should we build and why is a primary question. It's not something that you ask once you've already built something. Sometimes people ask that question, what should we build and why? The answer is profit, and there's a market for it, right? So they don't consider that ethical question. And the consequences of that are pretty clear. Just ask Meta, who this past week was fined hundreds of millions of dollars for not asking that question in the context of child protections. So it's a beneficial question. It's a necessary question if what you really want is your technology to serve human values. And it's a substantial question as you scale up that product if you don't want to incur the cost of harms. So if there's a question out there about the alignment between ethics and business, this is the business case for ethics. So asking the question is the first step. And then I think the next step for this is asking that question again and again and again. Frequently, what I find is that in advising startups where there is a mission drive at the beginning, what happens is that that mission is honest and pure and thoughtful at the beginning, and then investors come in, or then the questions about technical capacity of the product come in, and mission drift occurs, meaning that you start off with the ethical questions, and then your incentives misalign those questions from the product that you need to build to, for example, get your next round of funding or something like that. So the next step is continuing to ask that question over and over again. The third point, and this is, I think, intuitive, but it's frequently not practiced, is workplace culture, meaning that everybody that you hire or include in the process of design has to have that normative framing and the ability to ask normative questions. And this is what I discussed in terms of sharing a vocabulary for asking those questions. So everybody you bring in should have that shared vocabulary. This is a cultural workplace question, and I think that it's an entirely possible one to build, but it involves developing the vocabulary, ensuring that people on board know that the true drive is it belongs to these ethical questions, that the product success is not in whether or not it can perform a technical function narrowly, but whether that technical function is serving the ethical, moral, and substantive purposes that you've described. And so creating that as a culture is a messy organizational problem, but I think probably one of the most important ones.
Well, the good thing is I am not a startup.
Yeah.
Yet. And I have no intentions of turning this into a product. This comes out of the Assist Lab by Sri Karnaryawan, whose sole purpose is to apply technology in the service of people who face barriers in life. Yeah. So I think I have a pretty good grounding there, but it's very helpful to hear that I need to not only consider these things at the start, but in the middle, at the end, all the way through. That advice alone, I think, is going to help guide how I develop this, how I document it, how I write about it, and in fact, how I deploy it. So sure. Thank you.
Sounds like an exciting product, an exciting dissertation.
Are there any more questions? Okay, hold on. Go here, but you come up here.
Sure.
Okay, so a lot of your talks about the people designing the technology. I work for a public library. How do you incorporate the idea of being a consumer versus a digital citizen for how libraries guide people that are at the end result of these systems?
Yeah, great question. And I would love to talk to you. You know more about public libraries than I do. So I would love to learn a little bit more about what some of the challenges that you're facing in the context of practicing library science actually is, and engagement with the population. I think that the question, though, is not fundamentally different from the question that I face when I talk to students in my classes. In a sense, they're also end users. And the answer is always, for me, starting off with thinking about them not as theoretical persons engaging with my system, but actual real persons. Every semester, I design a syllabus, okay? That's my start. I imagine the conversations that we'll have, the books that we'll read together, the questions we'll deliberate. And then on day one, I no longer have a theoretical syllabus anymore because I have actual people before me. Not theoretical people, actual people before me with actual needs and actual personalities. And I have to adjust my theory in order to suit the actual people before me. And so I think that the first the first step is knowing the population that you're serving very well. It sounds like you already do that. And then the second is knowing that population, but also knowing the people who continuously use those things, not theoretically, but individually. So I think that this is about relationships. I think that this is about getting to know the community, asking for the community to provide feedback, and then providing integrative critique, commentary, and information so that that population can come to its context in the library with an understanding of what they're doing again. And I think that if you're working in the library, my guess is that you are encountering people on a day-to-day basis. And some people just want to know where the bathroom is. Some people want to know how to navigate the card catalog system or the updated information network system that infers from the catalog system of days past when I started going to libraries. And some people really want to understand how to navigate the stacks. And they're coming to you and they're asking questions, and I think that each of those encounters is an opportunity to understand and to connect with and to open up those questions for people, but also to learn about that community and to develop programs, structures, and infrastructure that speaks to those things. And it sounds like, if you're asking that question, from your question itself, I can guess that those are things that you are already doing, but I think that those are the fundamentals.
Thank you.
I'm actually curious as to how much interaction you get, not just between technology and ethics and philosophy, but the history department. Just because this is far from the first time the human species has confronted data storage and communications revolutions, and they're always destabilizing. For example, you have I think it was about 1070 in England, you have the Doomsday Book. You have the collection of data that completely facilitated the wholesale replacement of one ethnicity of leadership. You have the data storehouses that were burnt down even during the reign of Richard II, where people, even back then, were aware of the sensitivity of their data. You had the printing press, which we see now as a wholesale public good, but it destabilized Europe for 100 years. Radio did exactly the same thing to Europe during the 1930s. And I'm wondering how much interaction you've had with the history department, just because, again, humans have confronted this before, and there's probably a lot of lessons in there that we could take from what's already happened. You know, we're not flying blind. It's very easy for us to go, oh my God, AI, we've never had this before. We have.
Yeah.
So I'm curious about that.
It's a great question. It's changing. When in 2019 I founded my Center on Ethics and Technology, I had a lot of skeptical engineering departments saying, oh, wait a second, we don't want all of these humanities people invading our territory. In 2026, it's the history departments and the English departments that say, why should we care about these systems at all? Let the other side do this. We object to human knowledge being, commodified and regurgitated by generative AI. And so, the divide and the epistemic divide is real. It's institutional. It's reproduced in the workforce, as I've mentioned as well, to, I think, catastrophic ends. And it's changing, I hope. I think that there's some people who are activist-oriented in terms of transforming the ecology of education. And it's going to change, I think, whether or not history departments or engineering departments want it to, because the next generation of work is not going to sustain people who are narrowly trained in one field. My view, looking at the workforce and coming out of this study, one important thing that I take away from this is that the future of work will not tolerate people who just know how to code or just know how to technically implement something, because now anybody has the tools to develop that code. So it's just not sufficient. We see this being reproduced in the job market right now, where first-year engineering students who historically had the lay of the land in terms of the job that they were going to get after they graduate with whatever salary they wish to demand are not going to be able to command that anymore. So the job market is going to force a major change. Humanities students have always known, or have known for the past 30 years or so, that it is not sufficient to have a humanities degree and expect that you can get whatever job you want in the market, right? Unless your preferred job is waiting tables or preparing coffee. Those are wonderful activities, but graduating with a four-year degree from a college like Harvard is, I think, not, that is not the job sector that folks graduating with English degrees had aspired toward. And this market structure is, I hope, going to push universities to do something different than they have been doing. The big problems of the 21st century are problems that require interdisciplinary understanding in order to navigate. It's not enough to know how to build a climate technology if you don't understand how policy works and why people might object to talking about or thinking about climate change. So you have to know the history of climate change. You have to know the history of policy in that regard. It's not enough to know the policy without also knowing what technical instruments are available and what the limitations of those technical instruments are. And I'll just say one last thing with the time that I have here, which is you bring up the multiple iterations, historically conditioned, that we have of changing revolutionary information systems. And sometimes when I talk to history students or history professionals, what they will say is, we know how terrible the printing press was and the kind of chaos that was caused in the information ecology as a result of it. And when I talk to engineering students or engineering professionals, they say, well, this is not anything. Sure, we'll have a little bit of havoc, but remember the printing press? Everybody thought that it was going to be chaos when the printing press arrived, and we ended up just fine, if not better, as a result of it. I think the truth, as usual, lies somewhere in between those things. We have, as you pointed out, historical reminders that in every single informational revolution, people incur costs. And those costs are real, and they happen over and over and over again across history, even as these instruments enable us to come closer to things like universal literacy. So I say, let's have it both ways. Let's remember that informational revolutions ultimately allow us forms of literacy and forms of understanding about ourselves and the world that we would not previously have been capable of. But let's also remember that they encourage damage, frequently to the most vulnerable among us. And so knowing that history and having it available to us, let's not be Luddites, let's not throw out the revolution and what it's giving to us, but let's use that history to help us navigate it with protective means, asking the right questions, understanding that history in service of doing better this time.
And with that, we have reached our lunch. Deb, you're gonna hang around,
sure.
right? Yeah. So, lunch, because of the rain, has been brought into the courtyard.